Hi, in this lecture I'm going to show you how to navigate around in the binary with Radare. Even if we cannot execute the binary, from the infos we've seen in the previous lecture, we already learned a lot, even if we cannot execute the binary. We found out that the application does something on the network, that there is some kind of login, and there is no binary protection in place. As we said, our first target can be the login mechanism, basically to find out how to log in without having the credentials. So let's start reversing the program. So I start Radare with r2 server.exe. And when Radare is started, it will put you to the entry point of the application. Let's do the analysis. All right. And just to get things straight, the server.exe is not running at the moment. So how we are using Radare right now, the reverse program is not being executed. We are basically just disassembling it. This is the one thing you can do even if you cannot execute the program for any reasons. So as I said, we are going to learn how to navigate in the binary. So to move around in the binary, to basically change the location where we are standing right now, we need to use the seek command, which is the S. And after that, we can give either a memory address or a reference or something. So we could say S sim main, which is a reference to the main function of the application. So with that, we can jump to the main. As you can see, the address changed. So now we are in a different address where we were before, because now we are standing at the beginning of the main function. With main, you can usually also do s main. However, the main function is not so interesting for us right now, or at least I think it's not. So let's list the functions again. If you remember, it was AFL for analyze function list. So these are all the functions in the application. As you could see, some of them are from libraries and some of them are implemented in the server.exe. So if you start looking at the function, there is something which could be interesting for us, sim authenticate. So let's go there. Again, our address changed. And now, what do you think? How could we print out the assembly code of this authenticate function? So it might start with print, which is the command P. And if you start looking here, there is a disassemble and opcodes. So that could be PD. And here there is a PDF disassemble function. So let's try that. And as you can see, PDF shows exactly what we are looking for. So this is the authenticate function. It even gives us some information about local variables, and there is one argument to the function. And this is basically the code of this function. So since this is not an assembly course, I'm not going to spend so much time with explaining the assembly language. We're going to focus on how we work with Radare instead of how the assembly language works. So we did PDF. What you can also do is to PDF at. At in Radare literally means at. So after that has to come some kind of location. So we will say PDF at sim.authenticate. And that's going to print the same because we printed the same function. The important thing is that when you use at and the function name, then you don't have to be there with your cursor, let's say. So you can print any other function in the binary without actually jumping there. That could be good when you are disassembling a function, but quickly you want to check out another function. Then you can do that with the at, and then you don't lose your position in the code. After the at symbol, there could be a memory address, something which holds a memory address, like this reference or like a register or anything basically which points to a place in the memory. So if we start looking at this authenticate function, there is some string length check, then there is some writing, so we are printing something out. And after that, there is a function called check username. So that sounds interesting because that's what we are looking for right now, to figure out how we could bypass the username question. So let's go there. So I will seek to the same check username. Again, we jump to another location in the binary, and we can print that function as well. So let's try to understand the concept of this function. Here is some kind of read. That could be when we type in the username. And if you come here, there's a printf. And you could see here, it's pushing the location of a string to the stack. So this is just another reference or label, let's say, created by Radare, which points to a string in the binary. And in a comment, Radare also shows you what this string is, and it's the reading username string, what you would see on the server side when somebody types in the username, then in the log it will be printed that it's reading the username. Okay, so probably it reads the username, then this log message is printed, and there are some puts. That's not too interesting. There's a string copy here, and here it calls another function called compare username. Again, that's very interesting for us. And what could be more interesting for us is the arguments of this function. You can see that both arguments are pushed onto the stack as EAX. And one is a local variable 416H. And what is the local variable 416? This is also just a variable name generated by Radare. Oh yeah, it's the string copy is gonna probably copy something in this variable. But what is more interesting is the other argument, which is pushed on the stack here, and which comes from the variable 41C. And as you can see, the 41C variable is populated here just a few lines above with a fixed value. So this value could be interesting for us. Let's try to figure out what that is. So just to prove again that the most valuable command is a question mark. It can be used to calculate values. So we could use question mark and then the value we have seen and just enter. And then it's just going to do a lot of various transformations. What you can use to look at it and see whether anything of it makes sense for you. And if you start looking, there's this one when it's translated into ASCII characters, and it says job, which is kind of familiar, maybe because we are reverse engineering the application of Java. But the question is that all? We could try. So I will just start the server.exe, and from another location I will go and see localhost 14884. Yeah. And I say job, and it didn't work. And you see here was the log message, what we have seen in the code. So if we go back and we look a little more at that part, maybe it brings something to us. Because what's sure is that it seems like this value is used as one parameter for the compare username. So we would expect it to be a username which is used to compare against the user input. But what's with this one? So you could see that was a double word, and this is just a word, and it moves the OX61 to 418. By the way, if you come up here, you will see the naming of the variables. So 418 means EBP minus OX418. So if we add this 61 to our previous string here, then what you get is Java. So what happens here probably is we are populating a string at this memory address, so on the stack. And here at the second line, we probably just add another character to the string. So to check that, we can go back and connect to our server again and try the other username, which is Japa, and it worked. So it's great. We basically figured out the username. If you come to the server side, then you will see that reading username, Japa, comparing username is correct. So by reverse engineering the check username function, we figured out that the fixed value Japa is passed to this compare username function to compare it with our input string. So our next goal is going to be to figure out how to bypass the password check, because now we know the username, and we're going to do that in the next lecture. But before we go there, I just want to show you something else with the question mark. You could also do things like OX 10 plus 6, and it will tell you that it's OX 16. So you can use it to do quick calculations as well. Another thing I wanted to show you in this lecture is to make comments in the assembly code. Because if you used IDA before, then a very good thing is commenting all the assembly code you understood. Because like in 5 seconds, you probably are going to forget what you figured out at this part of the code. So it's really good to add as much comments to the assembly as you can, so that when you come back to this part, you could quickly understand again what was going on. So I want to add the comment to the place where we've seen the username, which is here. So I want to create a comment at this address. And the comment is surprisingly starts with C. And CC will add or remove comment. And you can specify the address here. So I do CC, and I will say username, this is a comment, is Java, and I will say at this address. If you don't specify the address, then it will make the comment there where you are standing right now. We are standing at the beginning of this function, so that's not the best place for the comment. That's why I'm using the at and address. All right. If I print the function again, you will see here that here is our comment that the username is Java. All right. In this lecture, we have seen how to move around in the binary, how to look at the assembly code, how to make comments. So I recommend you to check out other functions just to try what you learned. List the functions again, jump to those functions, disassemble the functions, and try to look at what they are doing. And after that, join me in the next lecture. See you there. Bye.